There is a belief we rarely question, that the deeper you go, the quieter the world becomes. Sound fades. Movement disappears. Everything settles into silence. If that belief were true, then there should be one place on Earth where silence is absolute. Not a desert, not outer space, but the deepest point humans have ever reached, beneath the ocean. More than 10 kilometers below the surface. Crushed by pressure. Sealed off from weather, from ships, from life as we know it. No waves, no engines, no voices, just water and depth. For scientists, this place represented something rare, a natural limit, a point where physics should finally win, where sound, no matter how powerful, should simply disappear. And so they made a simple assumption. If we listen there, we will hear almost nothing. Lowering a listening device to the deepest point on Earth was the first idea they considered. Not the final option, not the next step, but the starting point. There was no reference data, no safety test at a comparable depth, no precedent for simply listening in an environment like this. Only one assumption. If silence existed anywhere, it had to be there. On paper, the plan looked reasonable. A single hydrophone. No signal sent out. No interference. No interaction with the surrounding environment. Just lower it and wait. But at that depth, the ocean does not operate on human intuition. Pressure does not increase gradually. It multiplies. Materials no longer behave the way they do in a laboratory. Sensors believed to be stable can fail in ways no one can predict. And most importantly, once the device was released, there would be no second chance. No adjustments, no repairs, no way to know what was happening until everything was already over. Still, the team moved forward because the question they were asking sounded harmless. How quiet could the ocean really be? What they didn't realize was that this experiment was not truly measuring silence. It was testing whether the deepest place on Earth had ever been beyond human reach at all. Once the decision was made, there was no gradual way forward. Lowering the device was not the dangerous part. Letting it continue to descend was. With every kilometer, the environment changed. Pressure didn't just add weight, it rewrote the rules. At these depths, steel behaves differently. Ceramics flex instead of holding firm. Electronic systems respond in ways engineers can't fully simulate on land. That's why the descent had to be slow. Too fast, and pressure changes alone could fracture the sensor before it ever reached the bottom. The hydrophone passed depths where sunlight has never reached. Then depths where even submersibles rarely survive. 8 kilometers. 9. By the time it crossed 10, the device was operating beyond the conditions it had ever been tested for. There was no live feed, no confirmation signal, only calculations, and the assumption that the system was still intact. At this point, the experiment could no longer be stopped. If something failed, it would fail silently. If the sensor cracked, there would be no warning. If noise contaminated the data, there would be no way to separate it later. Everything depended on the moment the device finally settled near the ocean floor. Because from that point on, whatever it heard would define what deep really meant. The most recent deployment didn't happen decades ago. It happened in 2020. By then, the technology was more refined. The risks were better understood. But the question was still the same. This time, the hydrophone wasn't left recording continuously. Instead, the team chose a controlled approach. For 3 days, the device was lowered to the seafloor. Each day, it was activated for 3 hours. Then the data was recovered, and the wait began again. Every deployment carried tension. At that depth, there was no guarantee the equipment would survive. Pressure could fracture the sensor. Electronics could fail silently. And if that happened, there would be nothing to analyze. For the researchers on the ship, those hours stretched. They watched the conditions. They watched the clocks. And quietly, many of them expected the same result. If silence existed anywhere, this should finally confirm it. The ocean above was calm. No major storms. No unusual surface activity. The first 3-hour recording ended. The data came up, and almost immediately, something felt wrong. The background wasn't empty. Not faint. Not random. Low-frequency energy was already there. Structured. Persistent. The second day, the same patterns appeared, under the same calm conditions. By the third deployment, no one called it noise anymore, because the data was consistent. Sound was reaching the device, even when nothing appeared to be happening above. That was the first warning. Not dramatic, not catastrophic, but enough to suggest that silence was not simply waiting at the bottom of the ocean. What was recorded in 2020 was not something entirely new. It was the most recent signal of a story that had begun years earlier. To understand it, the timeline had to move backward, back to 2015. During the earliest deployment, the research team left the hydrophone, recording continuously for 24 days near the deepest part of the ocean. This was no longer a matter of a few hours at a time. No short tests. No brief windows. It was an uninterrupted stream of data. And it was here that the full picture began to emerge. Over those weeks, the ocean above was anything but stable. Large weather systems formed. Winds intensified. Powerful storms developed, far from the instrument's location, at the surface. But in the recordings, they were not distant. Each time the storm strengthened, the soundscape at extreme depth changed with them. Low-frequency energy rose sharply, not faintly, not slowly, almost immediately, as if the deep ocean were responding directly to events happening far above it. Then came the unmistakable signs of human activity. Within the long recordings, rhythmic mechanical sounds appeared. Regular, directional, impossible to confuse. Ship propeller from major shipping lanes, hundreds, sometimes thousands of kilometers away, in frequency ranges that were once assumed to fade with depth. But they didn't fade. They persisted throughout the data set. Then came signals that did not belong to weather or to shipping. Short bursts, highly structured, repeated patterns, active sonar and air gun pulses used in seismic surveys, generated at the surface and recorded more than 10 kilometers below. At that point, the question was no longer whether the equipment had worked. The instruments were functioning perfectly. The problem was the assumption. Depth had not isolated the ocean. It had not filtered out the world above. In many cases, it had preserved it. Sound was not erased. It was transmitted. When these findings were compiled and released in 2016, they challenged a deeply held intuition. And by 2010, formal scientific analysis had confirmed it. The deepest point on Earth was not quiet, and it was not separate from human activity. The consequence of the experiment was not a dramatic discovery. It was the collapse of a long-held belief that if humans went deep enough, their presence would finally disappear. By the time the recordings were complete, the question was no longer technical. The equipment had survived. The data was intact. The measurements were clear. What remained was the human cost of reaching that point. Days at sea stretched differently than days on land. Time loses its shape. There is no escape from the horizon. No place to step away. Only waiting. Waiting for the weather to hold. Waiting for the instruments to surface. Waiting to learn whether the device had endured another descent. Every deployment carried the same risk. If the pressure cracked the sensor, there would be nothing left to recover. If the electronics failed, weeks of work would vanish silently into the water column. There were no second chances at 11 kilometers down. And still, they kept going. Through long nights, through rough seas, through storms that forced them to secure equipment and trust calculations made days earlier. Not because they expected a breakthrough, but because the question mattered. Where does sound finally stop? At what point does the ocean truly become separate from the world above? But the data had already answered that question. Silence was not waiting at the bottom. There was nothing left to isolate. Every additional deployment would only confirm what they already knew. Depth was not a boundary. It was a conduit. At that point, continuing the experiment would not reveal something new. It would only repeat the same truth under increasing risk. So the work slowed. Not out of fear, but out of understanding. Because sometimes, the limit is not how far you can go, but knowing when you have gone far enough. That was the stop. The experiment ended, but the questions didn't. We now know that depth does not guarantee silence, that even the deepest place on Earth is not isolated from what happens above. Sound travels farther than intuition allows. Storms leave signature where sunlight has never reached. Human activity echoes in places we once believed were untouched. But knowing that raises a deeper uncertainty. If sound can reach the bottom of the planet, what else can? How much of the deep ocean is truly separate from the surface world? And how much of it has already been shaped without us noticing? We still don't fully understand how continuous noise affects life at extreme depths. We don't know how long those signals persist or how ecosystems that evolved in darkness and pressure respond to a world that is no longer quiet. And perhaps the most uncomfortable question remains unanswered. If even the deepest point on Earth is still listening to us, is there anywhere left that hasn't been reached? The instruments stopped recording, but the ocean didn't stop listening, and neither should we.